Welcome back, children. Now the next topic is some functions and their graphs. So before that we have to learn what is a real function. What is a real function and a real valued function? What is the difference between that? So a function which has either r, here r means set of real numbers. So a function which has either r or subset of r as its range, that is known as real valued function. So what is a function? A function f from a to b means every element of a has one and only one image in b. Then we know how to write the domain, range and codomain of the function, then image and pre-image. That much we studied. Here real function and real valued function. So for f, a function which has domain and range, if range is either r, that is set of real numbers, or subset of r as its range, that is known as real valued function. If the domain is also this r or subset of r, that is known as real function. So real valued means only range is r or subset of r. Real function means both domain and range are r or subset of r. Now some functions and their graphs. So first function is identity function. What do you mean by identity function? A function f from r to r is said to be an identity function if f of x is equal to x for each x belongs to r. That is the definition. That is a function f from r to r. R means set of real numbers. A function defined like this, f of x is equal to x for each x belongs to r, then this type of function is known as identity function. This means if I give x as 1, the answer part also 1. So f of 1 is equal to 1 means 1 is the, what is the name for this one? F of a is equal to b. If ab belongs to f, then f of a is equal to b. That b is known as image of a under f, or a is known as pre-image of b under f. So here f of when x is 1, this f of 1 is also 1, f of x is x. Whatever x here, that same is the answer. So f of 1 is 1, that is I can write 1 1 as an ordered pair. Then if I give 2, here also 2, f of 2 is equal to 2, f of 3 is equal to 3, or f of minus 5 is equal to minus 5. F of root 3 is equal to root 3. Whatever value of x, f of x also, that is image. This f of x means image. X is the first element and the second element is the answer part. So if I give x as 1, f of x is 1 itself. F of 1 is 1. Okay. Then x is 2, f of 2 is 2, f of 3 itself, like that. So I can give x as any real number. No restriction for this. I can give integers, rational numbers, root values. Okay, anything I can give. Anything means the superset of numbers, that is the largest set is set of real numbers. So I can give any real number to this x. Okay, that x is the answer part also. Answer part means the second number also that. So second number also real numbers, first number also real numbers. So what is the domain and range of this function? Domain means set of x values. Which all values we can give to this x? I can give any real number. So domain is equal to r. Then what is the range of this function? Range means set of second elements. What about the second elements? That also any number. Whatever value here I am giving, that is the answer also. Understood, children? F of, if I give root 3, that is x is root 3. F of x is what is defined? F of x is also x, so f of root 3 is root 3. So this how can I write as ordered pair? Root 3 comma root 3, isn't it? So the image of root 3 is root 3 itself, pre-image also root 3. So for this x I can give any real number, the second number also any real number. So domain is R, range is also R. Is this clear? So what do you mean by identity function? It's a function from R to R, set of real numbers to set of real numbers, such that f of x is equal to x. For each x belongs to R, that means x is a real number. So domain R, domain of this function R, range also R. This f of x you can denote as y, no problem. Okay, the second number, usually for ordered pair x comma y, that way we represent. So this f of x you can denote as y. So how can we draw the graph of this function? F of x is equal to x, or we can write as y is equal to x. Then how to draw the graph? X axis, y axis. Okay, y is equal to x. We can draw the table. When x is 0, y is also 0. When x is 1, y is 1. When x is minus 1, y is minus 1. The same value you have to give. So 0, 0, 1, 1, then 2, 2, 3, 3, like that. Then minus 1, minus 1, minus 2, minus 2. So when we join it, what we get? We get a straight line. Okay? We get a straight line through the origin. Through the origin. So for identity function, what you have to learn is what is the definition of identity function. Identity function means a function from R to R is said to be an identity function if f of x is equal to x for each x belongs to R. Then what is the domain and range of the function? Domain is set of real numbers, range also set of real numbers. Then what about its graph? When we draw the graph of f of x is equal to x or y is equal to x, y is equal to, in 10th standard you studied, y is equal to a constant into x, is always a straight line passing through the origin. Second function is constant function. So a function f from R to R is said to be a constant function if f of x is equal to a constant. Okay, here c is a constant, and for each x belongs to R. Here this second number is always a constant. For example, f of x we can denote as y. So y is equal to 5. These are all functions. In 10th standard you studied how to draw the graph of y equal to constant, x is equal to constant and all. So look here, y equal to 5 or y equal to minus 3, these type of functions, that is known as constant function. So what do you mean by constant function? A function f from R to R defined as f of x is equal to c. It can be any constant. Okay, for each x belongs to R. So for this x I can give any value. Okay, I can give x as 1. But this right hand side is no change in the right hand side, it is always a constant. For this y is equal to 5, I can give x0, x1, x2 like that, but y is always 5. So f of 2 is c, f of 3 is c, f of 1.5 is c, or f of root 2 is c. So for this x I can give any real number, but answer part, the second number is always this constant. So example of this constant function is y is equal to 5 or y is equal to minus 2, that type of function. So what is the domain of this function? Domain means set of x values, which all values we can give to this x. We can give any real number, so it is R. But range, what is the range of the function? Range is always constant. It gives this constant value. So that is a number. If y is equal to 5, y value is known as range, and range is set of, it is a set. Domain and range are sets. So range you have to write as set. Which constant? Generally we have to write, this is an example only. So generally the notation C. Instead of C you can write K, whatever. So inside the set symbol you have to write. Okay. Now what is the graph? Graph, for the graph you have to take example like this, y is equal to 5. So what type of graph y is equal to 5? Y is equal to 5 is a straight line parallel to x axis, isn't it? If y is equal to minus 2, it's a line that is also parallel to x axis. So generally you can say the constant function, its graph is parallel to x axis. So what is a constant function? A function f from R to R is said to be constant function if f of x is equal to c, where c is a constant, for each x belongs to R. Then domain and range. Domain means which all values we can give to this x. That x we can give any real number, so it is R, but the answer won't change, it is a constant. So range is set that constant value. Example, these type of examples, y is equal to 5, y is equal to minus x, like that. Okay. Identity function is in this form, y is equal to x. That is known as identity function. Constant function is y is equal to a constant. So its graph is always a line, straight line parallel to x axis. Now the third one is polynomial function. Polynomial function. A function f from R to R is said to be polynomial function if f of x is of the form a0 plus a1x plus a2x square plus etc an x raised to n. Where this a0, these are constants, are all real numbers, and this n is a non-negative integer, then only it become a polynomial. Okay. For example, for this f of x we can write y is equal to x plus 3. Is it a polynomial? It's a linear polynomial. Then 2x square minus 5x plus 7. These are all polynomial functions. These all we studied earlier, but that time we call this as a polynomial only. So here, this here, you can call this as a polynomial function. Okay. Then what is the domain and range? Domain means set of x values. You can give any real number. I can give 1 or 0 or point value or rational number or root value, anything I can give for this x. Okay. So domain is equal to, domain is R. Domain equal to R. But what about the range? We can't, range means it depending upon the nature of the polynomial. Here only x plus 3. This y is equal to x square is also a polynomial. For this x square, the answer, we can give any real number to this x. Then x square is always a positive number, it cannot be negative. But when here, if x is a negative, large negative number, then you will get y as negative. So nothing can be said about the range of polynomial function, it depending on the nature of the polynomial. Only domain you have to learn. Domain is set of real numbers, range we can't generalize. Okay. Then graph means, graph is also we can't generalize. This y is equal to x square is a graph. Y equal to x square means xy. When x is 0, y is 0, x1, y1, 2, 4. When we give negative value, what about the negative value? Negative 1, 1, negative 2, 4. So, when we draw the graph, 0, 0, 1, 1, then 2, 4, 3, 9, like that. Negative side, negative 1, 1, negative 2, 4. 4 is not there now. So, we get a parabolic shape. Like this one graph you will get. That is a graph of y equal to x square. Like polynomial function and constant function, we can't generalize. Polynomial function, its graph is a straight line passing through the origin, and constant function graph is always parallel to x-axis. But this we can't say anything, and generalization is not possible. Then similarly y is equal to x cube. Okay, we can draw the graph y is equal to x cube, x comma y, and x is 0, 0, positive side 327, negative side negative 2, negative 8. Here negative side also the 0, 0, 1, 1, 2. 2, 8 means up here somewhere. Then minus 1. Minus 1, minus 1. Then minus 2, 8 mean here somewhere. So it is just like this. Okay. Like this one. Curve shape you will get. Not a straight line, it's a curve shape. That is the graph of y equal to x cube. Now the next is rational function. So polynomial function. What is a polynomial function? A function f from R to R is said to be polynomial function if it is of the form a0 plus a1x plus a2x square etc. an x raised to n, where a0, a1, a2 etc. an are all real numbers and n is a non-negative integer. Then domain is equal to R, but range it's depending on the nature of the polynomial. Graph also like that, we can't generalize. Then some examples: linear polynomial, quadratic polynomial, cubic polynomial. Then graph of y equal to x square and y equal to x cube. Now next is the fourth one is rational function. Rational function. Rational function means a function f from R to R is said to be rational function if f of x is equal to p of x by q of x. P of x by q of x, where denominator cannot be 0, and this p of x and q of x are polynomial functions. So rational function means a polynomial by a polynomial. For example, x plus 2 by x plus 3, or x square minus 5x plus 9 by x plus 1. These are all rational functions. So rational function means a function of the form p of x by q of x, where p of x and q of x are polynomial functions and q of x denominator cannot be 0. And for this one, graph also, it depending on the nature of the polynomial. It's very difficult to draw the graph of this one. Okay. Then What about the domain and range? Domain means looking to the denominator. Denominator cannot be 0. We can't give all the real numbers. You have to check at which all values of x the denominator part 0. That values you have to subtract from set of real numbers. So, domain and range we can't generalize. Domain we can't say it is equal to R, range also. Okay. So, for rational function, domain, range and graph all depending on the nature, the type of the function. Now, look the next page, children. So, you have to write what's an identity function. A function f from R to R defined as f of x is equal to x for each x belongs to R. Domain is R, range is R. What is the graph? Graph is a straight line passing through the origin. F of x is equal to x, f of x we can write as y. So, y is equal to x. The next is constant function. F is a function from R to R is said to be constant function. If f of x is equal to c, where c is a constant, for each x belongs to R, domain is R but range is set c, that constant. And the graph is a straight line parallel to x axis. Now, the polynomial function and rational function. Polynomial function R to R, a0 plus a1x plus a2x square etc. An x raised to n, where these are all real numbers and n is a non-negative integer. Domain is equal to, we can say what is the domain? Domain is equal to R, but range we can't generalize. Then graph also, that is depending on the nature of the polynomial. In your textbook y equal to x square and y equal to x cube, both graphs are given. So, that you can refer. Then rational function, a function f from R to R is said to be rational function if f of x is equal to p of x by q of x, where q of x not equal to 0, and this p of x and q of x are polynomial functions. Domain, range and graph, that we can't say anything about it depending on the nature of the polynomial. Now, the modulus function. A function f from R to R is said to be modulus function if f of x is equal to mod x for each x belongs to R. This sign you have studied in smaller classes, absolute value. So, what is the absolute value? Here we say mod. So, mod 5, that we write as 5 itself. Then mod 0 is 0 itself. Mod of negative number, we neglect this sign and we just write the positive value. For positive number we don't put the positive sign. For negative number only we indicate the negative sign. So, whatever value inside the symbol we neglect the sign and write, that is known as modulus. Okay. So, modulus function is defined as f of x is equal to mod x. Example, you can write some example. Mod 2 is equal to 2, mod 0 is 0, mod minus 1.5 is 1.5 itself, mod 5 by 4, 5 by 4, mod minus root 3, that's equal to root 3, like that. Here all right hand side, you check the right hand side, all positive numbers, not negative. Okay. So, this is the meaning of modulus. So, this modulus we can again define. How to define that? F of x is equal to mod x. This is again defined as when x is greater than 0. Look, 2 is greater than 0. So, what we get, that 2 itself is the answer. So, this mod x is equal to x itself when x is greater than 0. And when x is equal to 0 also, what is here, that is the answer. So, here we can write when x is greater than or equal to 0, whatever inside that symbol, that is the answer. But if x is negative, x is less than 0, look here, minus root 3. So here it is root 3. Okay? And here minus 1.5, that is 1.5. So how we write? We can't write, we neglect the sign and write the answer. Mathematically you have to represent. So mathematically how we get this minus root 3 to root 3? You have to multiply by minus sign. So whatever inside this, if it is a negative number, you have to multiply by minus of the number, then only you will get a positive number. So when x is less than 0, what you have to do? Mod x is minus of x. Here root 3 minus root 3 is less than 0. So answer is root 3 means minus of minus root 3. Then only we get root 3. So that is here minus x. I hope all of you clear that. So f of x is equal to mod x. This again we defined as two ways. If x is positive or 0, we just write that number itself. So that is x. This function is equal to x itself when x is greater than or equal to 0. When x is less than 0, then that is x is negative, the answer is always positive now. So when x is negative, that is x is negative inside this mod symbol, and the answer you have to get as positive number. So what you have to do? You have to multiply by minus sign. So here we write minus of x. Okay. Example. Here it is 2. 0 is 0 itself, but minus 5 is minus of minus 5. Then only we get as 5. Minus 5 modulus is 5. No need of these all steps. But how we get this 5? You have to multiply by minus. So here when x is positive or 0, just write that number itself. When x is less than 0, you have to multiply by minus sign. So minus x. So this is the definition of modulus function. And what is the domain and range? What is the domain? You can give positive number, negative number, 0, anything you can give. Okay. So domain is equal to R. But range means the answer. What about this answer part? That is always a positive number. It cannot be negative, 0 or more than 0. So you can write as non-negative real numbers, or you can write like this. You will get 0 as answer, then 0 to positive side, 0 to infinity you can write. Or how we write? Non-negative real numbers. Then what about its graph? Let's try draw the table. X and y, positive and negative you have to give. When x is 0, y means y is equal to mod x. This y is equal to mod x. So when x is 0, put x here. So mod 0, what is mod 0? 0. When x is 1, mod 1 is equal to 1. When x is 2, mod 2 is equal to 2. Then minus 1, what is modulus of minus 1? Multiply by minus sign, so you get 1. Then modulus of minus 2, multiply by minus, you will get 2. Then draw the graph. It is 0, 0, 1, 1, 2, 2, then minus 1, 1, minus 2, 2. So you will get, look, a B-shaped graph you will get. Okay. This is a graph of mode function. So once again, what is a mode function? A function f from R to R, it's defined by f of x is equal to modulus x, or we can say mod x. And it is again defined as when x is greater than or equal to 0, mod x is x itself. When x is less than 0, mod x is defined as minus x. Then for this x you can give any real number. So domain is real numbers and range is always the positive number, 0 or more than 0. So it is non-negative real numbers, or we can write like this, 0 to infinity. Then the graph is a V-shaped graph. Now the last one is signum function. A function f from R to R is said to be a signum function if f of x is equal to 1 if x is greater than 0 and 0 if x is equal to 0 and if x less than 0 minus 1. So actually it is like a constant function, but here 3 different sections. That is, when x is positive, the function is always a constant, that is we get the answer as 1, and when x is 0 it is 0. When x is less than 0 we get minus 1. For example, f of 0 is 0 itself. When x is 0 the function is also 0. When x is 5 is in which category? 5 is greater than 0. So what is the answer? It is 1. When x is minus 1.5, minus is this side, x less than 0, so the answer is minus 1. So answer is only 0, 1 and minus 1, only 3 numbers. That is, range is minus 1, 0, 1. But domain you can give any number, positive number you can give, 0 you can give, negative number you can give. So the domain of the function is R and range is equal to minus 1, 0, 1. And what about the graph? When x is 0, 0, mark as like this, and x is greater than 0, this is x-axis, y-axis. X is greater than 0 means this right hand side. So when x is greater than 0, f of x is 1, f of x means y, f of x we can denote as y. So y is equal to 1 if x greater than 0, when x is equal to 0, 0. Okay. So when x greater than 0, y is 1. Let this be 1. So here. But this point is not included. This point means 0. At x is equal to 0. At x is equal to 0, y is not 1. More than 0, only 1. So this point not included. So you have to draw one white circle. That means white circle indicates that is not included. Then when x less than 0, that is this side, y is equal to minus 1. So here you have to draw. Here this is y is equal to minus 1. And this point also not included. When x is equal to, when x less than 0, y is equal to minus 1. But this point means x is 0. When x is 0, y is equal to 0 itself. So this is not included. Draw a white circle. So like this you have to draw. Okay. So I hope all of you understood this modulus function and signum function.